So we have been talking about limits, continuity, and the beginning stages of derivatives. All right. In the beginning stages of derivatives, we learned that the derivatives represent. Remember what derivatives represent? The slope of a function at any given point. All right. So what the derivative does is it essentially says, okay, we can take this graph right here, and at any point, as long as we can figure out what the derivative is, we can figure out what the slope is. All right. So if we were to graph the derivative would be a graph of a bunch of slopes. All right. So what we're going to do is we're going to start off by looking at the graph of f of x, and then taking this graph of f of x and seeing if we can sketch the graph of the derivative. Because the graph of the derivative is going to be a graph of slopes. So if we can figure out an estimate of what the value of the slope is going to be, then we can figure out sort of what this graph is going to look like. All right. And what's going to happen is we are going to get to the point where we're going to be able to use the derivative to describe what f of x is. All right. So what we want to start off with, okay, is we have this function right here. All right. How would you describe this slope right here of this function? This blue line. It's a positive slope, right? So is it always positive? Yes. So the derivative of this function will always be positive. Okay. Now, can we figure out what the slope of this line is? This is a linear line, right? Finding the slope is pretty easy and big, right? So that's before you find that slope. It's positive all the time, right? What else do we know about this slope? This case is not one, but it's what? How can we describe this? Is it changing? So it's what? It's constant. Good. So the derivative of this function we just said is a positive number everywhere. It's always the same, so it's constant. All right. So the graph of a constant function is just a straight line. Correct? It's a straight horizontal line. So something that this graph could look like, the derivative of this graph could look like is, let's just say this. Because everywhere this is a positive function, right? The slope is positive. So my derivative of this graph shouldn't be positive. There should never be any part of my graph that's negative. The y value is always going to be positive, right? My slope is constant. So my graph should be constant. It shouldn't be changing. Right? So what we have here, now I'm going to erase this because this actually isn't the graph of that. You can find the slope of this real easy. Alright? We go up 2 over 1, up 2 over 1, up 2 over 1. So the slope of this line right here is equal to what? 2 over 1, 2. So what we know is that so the slope is that, right? So the derivative is equal to, so dy dx is equal to what? 2. Alright? Well, this 2 is a constant function. So it's the graph of y equals 2 would be just a horizontal line at y equals 2. So and this function in fact is actually let's say let's put it in terms of y. This function is actually y equals 2x. Alright? So if you were to find the derivative of y equals 2x, what's the derivative of y equals 2x? 2, just like we just said, and we can graph it, and there's the graph of the derivative. Alright? So come up with a conclusion real quick. We have a sort of a linear line with a constant function, or with a constant slope. What's the derivative of the graph always going to look like? Well, you have a constant function, constant horizontal line. Alright. Again, this is probably something where it might be beneficial if I print this out for you. So that's something that you might take. These next couple of days, I might not count for this, you can have this right up. But so we just grabbed our first derivative. Alright. Just by using what we know. Okay. So let's take a look at another graph. Alright. Again, notice. You guys said that the slope of this graph is always positive. So notice. This graph is always increasing. This function is increasing. And what do we notice about the derivative? It's always positive. Alright? And I'm going to emphasize that because there's some relationships here that we're going to start talking about in the next couple of days. Right, so here's another one. Alright? So here we have a constant function, right? And look at this, you have this in the line y equals -3. Okay? What is the slope of this line right here? The slope of this line is 0, correct? Always 0. Every x value is the slope is 0. So does that make sense? What is the derivative of y equals -3? 0. Alright? So the derivative is the equation y equals 0 at all times. So how do we graph that? Well, it's just going to be what y equals y equals 0. It's going to be a horizontal line along the x-axis. Alright. Again, that should make sense. But what you want to understand is, so the slope is your derivative value. That's the first derivative value. So that's your y value. So if you look at this, the slope at x equals -4 is 0. Therefore, at x equals -4 for the derivative, the y value is 0. Alright. So you have your x values, and then for your first derivative, your y value of your first derivative. This is kind of what we'll make a note of this. The y value of the first, actually, of f prime of x is the slope at x equals whatever, a. Alright. So what you need to sort of take with you is that whatever the slope is at a certain point, at a given point, that slope is the y value for your first derivative graph at that point. Okay. So not quite as easy of a graph. This is a pretty simple one, but here's what we need to know. What we need to see is this right here. All right. It has the slope's not constant all the time. Correct? The slope is changing. So this slope is not going to be a horizontal line. All right. So what we need to look at is, so we know this graph right here is supposed to be y equals x squared minus 6. But we don't want to rely on this, the fact that we know how to find the derivatives to be able to graph this. And we might, maybe this isn't like that, maybe it's just a little bit different. But what we know is that if we can estimate the slope at certain points, we can sketch a graph. Alright, so what I'm going to do is I'm going to actually do a line drawing tool. Okay. Alright. Do we see any points where any x values or the slope might be really easy to estimate? What x value are you looking at? 6? Of 1 divided over 2? Of 1 over 3?
Oh, that's 3. That's 3 over 1.
Of 3 over 1? Of 3 over 1? Alright. So let's just look at this. Let's take some points to look at. Alright. If we look at right here, let's look at x equals 8. Or negative. Alright. And we draw the so if we have this slope right here, we're going to have x equals negative 8. And remember, our derivative is the slope of what type of line? Who? The derivative is the slope of a function at a point, but it's the slope of what type of line? With the t. Tangent. Alright? So what we're going to do is we're going to draw some tangent lines. Alright, we'll look at a line that's tangent right here. So it's going to look something like that. Look at a line that's tangent maybe right here. So look at that. Let's look at a tangent line so here. So it's going like that. We got a tangent line right here. So it's looking like that. What is happening to the slope of each of these tangent lines? Okay, it's negative. Alright, so over here the slope is, so our slope is negative over here. What else is happening as, so if x equals negative 8, how does the slope of x equals negative 8 compare to the slope of this tangent line of x equals negative 2? So this tangent line right here, how does that tangent line, how does the slope of that tangent line compare to the slope of that?
That one kind of looks like down.
So what can we say about this slope compared to this slope? Which slope is more steep? This one. So this slope is more steep, which means it's more, like, it's going to be negative, but it's going to be what type of negative? So if I were to give you two numbers, would this slope be negative, let's say negative 8, or this slope would be negative 8? Which one is more steep? Negative 8 would be more steep than negative 2. So these slopes of each of these tangent lines are getting less steep. Right? They're getting closer and closer to what happens to this slope right here. What? The straight line, which in the slope of the straight line is what? 0. Slope of a tangent, or slope of a horizontal line is 0. Alright, so at x equals 0, we know the slope is what? 0. So let's start by graphing our derivative. We want to get this. I use our first derivative. We know that the slope of this blue parabola at x equals 0 is 0. Right? Now, what we can do is, okay, now you already said, Michelle, this slope over here on the left is negative, right?
Yeah.
So think of it this way: when you're graphing your derivative is your y values are equal to your slope values. Alright? So it's sort of like y equals m. So your y values are your slope. Your x values, those are just still your x values. So at x equals 0 over here, looking at our initial function, alright, this is f of x, our slope is 0. So at x equals 0, y equals m is our slope, so y equals our slope is 0. Alright, now let's just look at this one over here. Alright. Let's make an estimate of this slope right here at negative 6. Alright. Let's make an estimate right here. You just look from here to here. We'll just find an estimate It's, says you go up 3, 1, 2, 3, over 1, 2. Alright, that's look at it. So here, here. So we have up 1, 2, 3, over 1. Alright, so at this point right here, this area, it looks like it is going to be a slope of Alright. So up here it's going to be a little more steep. So let's just say at -6, you have -3. So, or, this is making a general sketch. We're saying that this slope is getting more negative, so it's getting less and less negative here, right?
Yeah.
So it's really steep up here, so this would be, if you just pick a number, it's going to be more negative than this slope, right? -9, we can just, let's just think in terms of more negative than this slope. This slope's more negative than this slope, this slope's more negative than this slope. It's getting closer and closer to it. Alright? So, it's just going to be something like that. That side. Alright, because if you look at it, let's just say at negative, right here we have -5. At -5, this slope is the slope of this function is more negative than at -3. So -3 is y value to the top. Alright. Over here, the function you make a bunch of tangent lines. These tangent lines are all going to have what type of slopes? Positive slopes. Alright. And the further and further we get up, the steeper and steeper it's going to get. So the slope is increasing. It's getting higher and higher, but it's increasing at the same rate. Alright, so you get a linear line. Now, this should make, if you think about this, this is going to be maybe x squared minus 6. What is the derivative of x squared minus 6? Alright, so 2x's are the function of our derivative. Well, if you were to graph 2x on the calculator, you're going to get a linear line that goes up to over 1, up to over 1, up to over 1. Alright, so we have a sketch here of what this derivative looks like. Alright, and again, we are not concerned about actually getting the full sketch or getting the accurate sketch right now. What we want right now is we want to just be able to get a general sketch, a general idea of what we got, our derivative is going to look like. Alright. So if you look at this, it's a negative slope on the left side of x equals 0. All of our y values are negative. All of our y values are positive on the right side of the y-axis because at x equals 0, the function starts increasing, so it's having a positive slope. Alright. So now I'm going to try and get to these functions. So let's think about this. All right. Are there any places where it's easy to identify what the slope is of a tangent line to this function? What? This is easy to figure out what the slope is right here. Where are the two easiest points to figure out where the slope of the tangent line is? 2 points on here where we would not have to estimate what the slope is. Here? You know exactly what slope that is? What is the slope? What is the slope of the tangent line of? So it's always easiest to look at your graph and say, are there any places where my slope is 0? Alright, and the answer is yes. Right here, and then it's all straight line. And there. Alright, so that's right there, at x equals 3, and right here at x equals -4. Alright, so our slope is equal to 0. Slope is equal to 0. This is fx. This is convex. So we know at x equals -4, our slope is equal to 0. Alright, remember, our y-axis is equal to our slope. what's our y value for
There.
0? And negative 4 is going to have point at negative 4 is 0. What is the slope at x equals 3? 0. So at x equals 3, this graph has a y value, the derivative of the graph has a y value of 0. Okay? So, now, let's look at this. Here, from negative infinity all the way to negative 4, are my slopes going to be positive or negative for my tangent lines? Positive. So that tells me that the y value of my first derivative should also be positive. All right. Now, if you look at this, if I were to draw in tangent lines here, are the tangent lines here? Are these tangent? Are the slopes of these tangent lines going to be increasing or decreasing? Well, how does that slope compare to that slope? Which slope is more steep? This way. All right. So the further out this way towards negative infinity I am, steeper my slopes are. The closer I get to this point, my slopes start to become smaller. All right. So my slope over here is going to start really, really high, and then as we get closer and closer to negative 4, they're going to become smaller and smaller. All right. And you kind of want to think about, we're saying my slope is becoming smaller, right? So up here, my slope is, slope like 10. So it's like saying slope at this number is y equals 10. And now it's down here, and it's like y equals 1 down there. So my slope is from being 10 to 1. So my slope is decreasing. Alright? Now, what happens just to the right of this function over here? Decreasing. So my slope is going to have to be what? Say that without you. Negative. So from x equals negative 4 to x equals 3, my slopes are negative. Alright? Now, what about here? My slopes from x equals negative 3 or x equals positive 3 to infinity, my slopes are all going to be what? Positive. So I know that from here to here, my slopes are going to be negative. Alright? So, and then once I get to here, these slopes are going to start going up again and positive. Alright, so, discussion. And you can look at this. You ask yourself, on my graph of my derivative, from negative infinity to negative 4, my y value, my slope value is positive, yes. Alright? Is my slope value at negative 4 on my derivative graph 0? Yeah. It is, right there. From negative 4 to 3, my slope of this line is decreasing. My slopes are negative. Well, my slope values here between negative 4 and 3 are also negative. Then I know from 3 to infinity, my slopes are positive. So my y value over here is at positive value. Alright. Maybe a little bit of sense? So if we look at this. Yeah, that's what I thought. Yes, what? I don't know what that function is. Doesn't matter what that function is, we still sketch the graph. Well, it makes me uncomfortable that you actually know what that function is. I think. Alright. So, what's the first thing we want to identify? When not a 0 is going to identify where the slope of the tangent line is what? Equals 0. So, where would that be? Well, we have one right there, here, 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 here. Alright? So, where does our slope equal 0? Our slope equals 0 at x equals negative 8. This is at x. And x equals -4, and x equals 0, x equals 4, and x equals 8. Alright, so right off the bat, I know that my first derivative is going to have a slope of 0 at -8, -4, 0, 4, 8. Alright. So, now, let's look at this. From -10 to -8. At -10 to -8, the slopes are positive, correct? So, I know that from -10 to -8, my slope is going to be positive. And I have to start positive and come down here. Alright? From -8 to -4, my slopes are what? Negative. So I know that the slope is going to need to be negative here. Alright? So, that. And then by the time I get back to -4, it better be at 0, because we already know it. X equals -4, the y value, my slope, alright? Now, from -4 to 0, my slopes are positive. So again, I know that this is going to look something like this. Alright? Then, from 0 to 4, my slopes are negative, so it better be negative on my graph. Alright? And then from 4 to 8, my slopes are positive. So again, positive. And then from 8 to -10, or 8 to +10, my slopes are negative. And again, right now, like we don't care what the attribute, like once at some point in time we'll be able to know what this graph is and get a graph on our calculator. Alright? Right now, all we want to do is get a general sketch of what this graph is going to look like. So again, what you do, the first thing you want to do is figure out where you're supposed to 0, because those are going to be accurate answers. They're going to be exact answers. Alright? Then you want to figure out, in between those, are my slopes positive or are they negative? And you just draw in the sketch. And you'll get good at this. I'm going to actually make a wild guess and say that this is probably the function 5 cosine x. And that this would actually be the first derivative, which would be 5 sine x. 5 negative sine x. Negative 5 sine x. And that trig stuff. Yeah, there's a number of stuff. Alright. So, but again, all you guys will be required to do on your homework test really is look at this, look at f of x, and pick out and match out which letter it goes with for the graph of that product. Alright? So, alright. So, right here. Well, we're gonna have 2 more. Do you guys think you can do this one? Before you, so don't even start graphing. So, what would be the first one to do? Find out where my slope is 0. So, right here, that whatever x value that is, right there. So, that looks like -7. This looks like what? Negative 1.5. This one is positive 4. Alright. -10 to -8. So, positive or negative? -10 to -8 is what? Negative. So, okay. So, we see that from -7 to 1.5 is also positive or negative? Positive. Alright. So, we can draw on what we think might look like. So, alright. Positive and negative.
Mr. Duvall, I have
negative slope. So it's going to be here. And then, you guys are going to get pretty good at that. Okay, this one has, it looks like this. So this type of function has 3 turning points. So I think we have 2. So we go here. This one is a cubic type of function, a quadratic function. There's a derivative. X on plus 3, 2, 2. So let's just look at this type real quick. Okay. So these are the nice. One, it gives you the actual points and points nice and easy. 2, these are all little linear line segments. Okay, so we can look at this. So all you do on these types is just say you find the actual slope here. You go up 1, 2, 3, 4, 5 over 1, 2, 3, 4. So my slope there would be 5/4. So then there's one over here 5/4 is what 1.25. So from -8 to -5, my slope will be 1.25. Alright, then you go to the next one. My slope here is 0. So you go like something like this. 0. And you do that line. Your homework, I didn't give you guys any paper, which I may copy that. I don't think I did. So you guys have homework notes for everywhere. Well, here, your homework is. Your homework is, you better write this down. Page 1 of 5.
Oh, I got it. Try to do it. Yeah. And then eventually give us our paper.
I will tomorrow. I have.
No, he's not here.
You sold my pizza, coach. My pizza. Friday. My mom said she gave me $8 for 2 pieces.
Which one was it? The actual test?